Okay. It says a differential function f has the property that f prime of x is always less than or equal to 4. I would make, sometimes it actually helps to make flashcards from problems, even though I tell you not to memorize problems, because they do give a good example of like a little memory trigger that you want to occur on some future problem. So I would build a flashcard right now. I would put this on one side of the flashcard. Then on the other side of the flashcard, I would write, therefore, 3 dots in the shape of a triangle means therefore. It's a legal symbol on the AP test. Yep. Therefore, every tangent slope and secant slope of f. So again, notice how I'm being very careful not to mix up f and f prime, or throw in the nasty words graph, function, or it. Every tangent slope and secant slope of f must be less than or equal to 4. So you need that flashcard.
Do we still need to make a flashcard if we got it right?
I would, honestly. Just partly for preparing for the AP test itself. Like I like to have like a nice deck that I'm going to carry with me the whole year, because we'll kind of leave this behind a little bit, then we come back to it. So I would. Somebody else? Okay. Then they say f of 6 equals 3. F of 6 equals 3, which the following could be true. And f of 3 equals 0. Somebody talk, I'll pay you. Please speak.
Yes, because f of 3 equals 0 is less than f prime. Because it has to be less than or equal to 4. And if f of 3 is equal to 0, that's less than 4.
So you're looking at the 0 being less than 4? 2 points, but no. It's okay. That would mean, like what you're looking at is the value of f is less than 4. We're not interested in whether the value is less than 4. We got to make sure the tangent slope and the secant slope of f is always less than 4. So this means the value of f is less than 4. That turned out to be true, but the problem is a bit flawed because that's how you got the right answer, just wrong reason. 3 points. Please, Mike.
So as you said, every secant slope and tangent slope has to have a value, if it's f prime, has to have a value less than 4. So if we just draw secant slopes from every point to point, then as long as they're under 4, then that has to be.
There we go. So what Mike says, we need to go check secant slopes. So secant slope is change in y divided by change in x. So Mike, how much does the x value change between these 2 points?
So that'd be 3 over 3.
So the x value changes by 3 because it went from 3 to 6. So the secant slope here is going to be a change in x of, let's go here, change in x of 3. And you notice that the y value went from 0 to 3 also. So change in y is also 3. Therefore, that secant slope is 1. We're good. That secant slope is less than 4.
Yeah.
3 points. Do we want to talk about it? Somebody? Okay.
How are you finding the secant slope? That's like,
It's okay.
I understand that.
F prime is the symbol that represents the slopes of f. So when they say f prime is less than or equal to 4, that precisely means every tangent slope of f will be 4 or less. Like f will have some shape where every tangent is 4 or less. Good? Simply turns out that there's a connection between tangent slopes and secant slopes because of how tangent slopes are found. Do you remember this picture?
Yeah.
How we talked about how we find the tangent slope by making secants? Because of that, if every tangent slope has to be less than 4, so does every secant slope.
Okay.
So what Mike did is he looked at the data and said, okay, all I have are points. I can't find tangent slopes with points, but I can find secant slopes. Well, let's go check those. So he checked this. So this is the only known point. The others we don't know. We're checking. So he checks between those 2 points and finds out that the secant slope is 1. So that works. It's like the graph would literally have a point here at 3, 0. Sorry, Dan, 1 second. And then another point at 6, 3. So 6, 3. Now, between those 2 points, the graph has some sort of curvature. I don't really know what that curvature is, but something. But the secant slope between those 2 is 1. Therefore, it's a safe bet that I'm okay. Like, that's reasonable because of this fact. Does that help at all?
Yeah.
3 points. Mia?
I was just gonna say, if you put it in a graph, it kind of makes it kind of like a table. Makes it easier to like see it all at the same time.
Mia's correct. That's precisely why they didn't put it in a table, because they knew it would make it harder. You know what I mean? If you put it in a table, it becomes easier to see what's happening. Three points for Mia. Somebody else, what else should we check? Like, we know this works. Now what do we check?
Two.
So which ones do I compare, Reed?
F7 is equal to -1 and F6 is equal to 3.
There we go. So from here to here, the change in x is what?
1.
Change in x equals 1. Change in y?
4.
Careful, -4.
Yes, fine. If it was 4, it's still
Correct. So -4, that's definitely less than 4. So that one works. 3 for Reed, 3 for Stockton. Now we check these two. Change in x is 2. Change in y is, funny, too much. Guess that wasn't very funny. Slope is 7. So.
Would it not be 10? Is it checking from the half of 6?
Oh, thank you. That was a bad mistake. Good work. 3 points. Anybody else? You know, a different question you want to talk about?
22.
Which one? 22?
Yeah, keep them down.